In this segment with Cuisenaire rods, I'm going to be continuing with part 2 of the fraction division concepts and how to do fractional division with the Cuisenaire rods. Last time we worked with whole numbers and proper fractions. This time we're going to be working with division of proper fractions. Quick review, we want to talk about the big ideas that we came up with last time. And it's the understanding that if I divide by a number bigger than 1, my answer is going to be smaller than my original. So if I'm talking about dividing by proper fractions are always going to be smaller than 1. So I should be expecting answers that are always going to be bigger than what my, if I'm dividing by a number smaller than 1, I'm always expecting my answer to be bigger than what my original is. And since I'm talking about proper fractions, I expect my answers for these questions are always going to be bigger than my original. Dividing by numbers larger than 1, which is what we did in the last segment, produces answers that are smaller than my original. So we should be expecting all of our answers to fit into this category right down here. If I divide by a number smaller than 1, all my proper fractions are smaller than 1 because that's what a proper fraction is. I should be getting answers bigger than my original. So here's my first question, 1/2 divided by 1/4, or if I look at it in the part A way, how many 1/4s are in 1/2? Now 1/4 is smaller than a half, and so let's come up with a reasonable answer. I know I'm dividing by a number smaller than 1, so I expect an answer bigger than a half, and I'm dividing by something smaller than a half, so I should be expecting an answer to be a little bit bigger than a half, and as a matter of fact it should even be bigger than 1. So looking at it with the rods, I like to use this one if I'm talking about halves, but I want to find out how many quarter pieces, and I can't cut that one into quarters. So I'm not going to use that as my 1. I'll use this one as my 1. So that's going to be my 1, and then therefore that's going to be my half, and my white, therefore, will be my quarters, because it takes 2 whites to make a red, and 4 whites to make a purple. So there's my whole, there's my half, there's my quarter. And my question, therefore, could be stated, how many quarters are in 1/2? How many whites are in a red? Well, I know there are 2 whites to make up a red, so my answer is going to be 2. How many whites are in a red? How many quarters are in a red? How many quarters are in a half? The answer is going to come out to being 2. So my answer comes out to 2 using that technique. Using our second technique here, 1/2 is a quarter of what size? I can probably start with this one, because if that's my 1, then this is going to be 1/2. My 1/2 would have to be quarter of what size? So if I'm looking for a quarter of something, that means I need 4 of them. So if I have 1, 2, 3, 4 whites, there we go. So if I have 1/2, which is a white, is a quarter of what group? So now it's 1/4 of my pile. That's the same thing as 2 of these, and so my answer is going to be 2, because we said a red is a whole, a white is a half, 1/2 is 1/4 of what size piece? 1/2 is a quarter, because it takes 4 to make a quarter. So 1/4 of what size piece? That would be 2 wholes. So again, our answer comes out to equaling 2. 1/2 is 1/4 of what size group? Well, if I have a group of 2, then my white would be 1/4 of that group. So again, my answer comes out to being 2. In this question, I've switched the order around. So now instead of 1/2 divided by 1/4, I have 1/4 divided by 1/2. I'm still dividing by a number smaller than 1, so I expect to get an answer bigger than my original, but now I'm dividing by a piece that's bigger than what I started with, so it's not going to be quite as large. So in our first example here, how many of size 1/2 groups can I make out of a quarter? I'm going to take my purple as my whole, because I need halves and quarters. So as soon as I know that I need quarters, I'd like to use the purple. So 1 is my purple, 1/2 is my red, therefore 1/4 is going to be my white. So now it's going back, how many 1/2 groups, how many reds can I make out of a white? Well, can I make a whole red even? no, I can't even make a whole red. So how many reds can I make out of a white? Well, I can make half of a red. And so let's take a look at our answer. If my answer is a half, is that reasonable to what I expected? I said I'm dividing by a number smaller than 1, so I expect to get an answer bigger than what I started with. Is 1/2 bigger than a quarter? Yes, the red is bigger than a white, so I'm expecting to get an answer bigger than what I started. I expected to get 1/2. That makes sense. It's a reasonable answer. It seems very confusing, but it's reasonable. Let's take a look at the second idea, the B type. We can use our same diagram here. 1/4 is 1/2 of what size? So here's my 1/4. My 1/4 is half of which of these pieces? Well, my 1/4 is half of a red, and a red is a half, so my answer would be 1/2. It's the same diagram for this one as it was for the A type style. 1/4 is 1/2 of what piece, or what size piece? Well, the white is 1/2 of the red. So what size piece are we talking about? We're talking about the red pieces, and the red pieces are called a half. So again, my answer would be 1/2. For my last example, I'm going to use some fractions that the pattern blocks don't really work too well with. It's kind of hard to get fifths in a pattern block. So how might we be able to use our Cuisenaire rods to do this, where we wouldn't be able to do them with the pattern blocks? So our question is 3/5 divided by 1/2. Again, I'm dividing by a number smaller than 1, so I expect an answer bigger than what I'm starting with. So I expect an answer bigger than 3/2. Now, 3/2 is also bigger than a half. So if I want a half divided by half, I expect to get an answer of 1. So bigger than 1 divided by half, I should get an answer a little bit bigger than 1. So I know I should get an answer bigger than 3/5, but I also now figure I should get an answer bigger than 1 as well. So there's my discussion around what would be a reasonable answer if I understand what it is I'm doing. So let's take a look at what it would look like with the rods. So if I'm dealing with fifths and halves, cutting things into fifths and cutting things into halves are probably going to have something to do with these guys. I can cut that into fifths, I can cut that into halves, but I can't cut that into fifths. So what I'm going to do is I'm going to make that my whole. This therefore will become my half, and this will come to 1/5. And so those are the players I'm going to be working with right now. So I'm asking how many halves, how many yellows are in 3/5? Well, that's only 1/5. So to get 3/5, I need to have 3 of those then. Okay. So my question then is, how many yellows can I make from 3 reds? Well, I can see I can make at least 1, and I'm going to have a piece left over here at the end. So my answer is going to be 1 and a piece, which is what we said when we asked about it. Is my answer reasonable? We figured out we're going to get an answer bigger than 3/5. We actually figured out it's going to be even bigger than 1, and so we're getting an answer bigger than 1. So how many yellows can I make out of 3 reds? Well, I can make 1 yellow and a bit. But what we're asking is how many halves, how many yellows. So this bit has to be in terms of yellows. So a white in a yellow is the same thing as 1/5, because it takes 5 whites to make a yellow, so each white is going to be called 1/5. So therefore, how many yellows can I make? Well, I can make 1 there, and this white is 1/5. So my answer to this question is I can make 1 and 1/5 yellows, or 1 and 1/5 halves. Remembering, when I'm doing my division, I'm finding out how many groups of a half. How many size 1/2s can I make? I can make 1 and a 1/5 of 1. So it's 1 1/2 halves is really what we're making. And this is what makes division by fractions difficult. It makes division difficult, but it makes division by fractions even more difficult. Because what my answer is, it doesn't even necessarily come out to 1 1/5. 1 1/5 what's? Well, it all depends on what it is we're dividing by. So my answer is 1 and 1/5 halves, 1 and 1/5 yellows, 1 and 1/5 yellows. Let's take a look at the second type. The second question says 3/5. Well, we know a red is 1/5, so what we're talking about then is this 3/5 that we had here before. 3/5 is a half of what number? Well, that's what we can, if we want, we can think of it that way. And so we need another set of those to be a half. So what do we get? We get this number here. So we said 3/5, 1, 2, 3, is half, so therefore we need another one, 1, 2, 3, so there's my total. Each of these are a fifth, so I have, for a total, I have 1, 2, 3, 4, 5, 6. So my answer could be written as 6/5, because each red we said was a fifth, and I have 6 of them. Now 6/5 is enough to make one whole. Remember, this is a whole, so let's take that and we'll drag that down. So I have enough to make one whole and 1/5 left over. So again, my answer comes out to 1 whole and 1/5, both ways. So again, whichever technique makes the most sense to you at the time. Some questions lend themselves more to one style than the other style of thinking about it, but the more you can go back and forth from both of them, the more flexible you will be and the more powerful you'll be over your mathematics. Now before we finish off, I just want to show the standard algorithm that we normally talk about. If a question looks like this, 3/5 divided by a half, we would take 3/5 and then we change the division to a multiplication, and instead of 1 over 2 it becomes 2 over 1. Now, this is the idea that we talked about earlier in the previous segment. When I said 10 divided by 2, 10 divided by 2 gives me an answer of 5. But 10 times 1/2 also gives me the answer of 5. So if I divide by 2, that's the same thing as multiplying by a half. If I divide by a half, that's the same thing as multiplying by 2. So this gives me the answer of 6 over 5, which is exactly what we had here in our answer that we used with our blocks. So our standard algorithm is multiply, change our division to a multiplication, and multiply by the reciprocal. Because if we change the operation, we can change what we're doing. And that's the standard algorithm, and we can make a connection. Once we've got these things worked out so we can see what the numbers, we can talk about that standard algorithm. And it's a standard algorithm because it works no matter if it's proper fractions or improper fractions. It works if the numbers cancel or if the numbers don't cancel. If they're big numbers or little numbers, it all works the same way. So it's a standard algorithm, but many people don't understand why it works. And so we can talk about that more in your class. But basically it comes down to this idea of dividing by 2 is the same thing as multiplying by a half. Dividing by a half is the same thing as multiplying by 2. And we can go back to our previous pattern that we did with our tens to see how that pattern relates to one another.